Thank you for your time. I only went 30 seconds over, maybe 40. I opened the floor to questions. Hello y'all, welcome back to my YouTube channel. I have officially graduated as of the 8th. And I have finished my educating with the formal university part as of the 5th. So again. Today I'm going to be gracing you all with the results of my 5-part live stream series that's also on this channel. Check it out. There I researched this newish fandangled structural material that's colloquially known as mass timber. So with a few caveats to go, please enjoy my final college presentation. Caveat number 1 is, of course, this research is very limited and a first dive into this new topic. So any and all errors that exist or that can be found are my fault, not necessarily the researcher's part. And then 2, timber has recently shot up in price, so the estimates presented, like cost estimates presented in this project, may or may not be applicable any longer. So with that being said, enjoy. All right, welcome to my presentation on mass timber. All right, as a quick overview of the presentation, I'll be discussing the history and development of the material and its use cases and importance, as well as then having a deeper discussion on some of the key areas of interest, which provide the main draws for why this is a promising new construction material. And then finally, if time allows, I will quickly discuss the engineer's role in the optimization of the design and use of this new material. All right, so what came before? In the early 1900s, concrete and masonry dominated the construction industry with regard to its structural buildings, because you could construct one for relatively low cost for that per unit. Whereas in timber was unfortunately relegated to light frame construction cases, which generally also probably would include residential use cases. But fear not, the return of the timber. I was going to appreciate that little gif right there for a hot second before we move on. All right, so with the advent of laminar timber products, timber has, in the late 1900s, felt a resurgence in its use, especially in Europe, as they were the trendsetters of this technology. So what is laminar timber products? Essentially, they are thin slices of wood that have been glued together according to various standards and can be oriented in various directions to achieve different structural or mechanical properties. You can get up to 11 layers as shown in this left image, but generally you'll see them in 3, 5, and 7. Specifically, I would like to draw attention to cross-laminated timber, aka CLT. This is probably one of the more popular structural mass timber elements because the layers, as you can see, are oriented 90 degrees to each other, alternating, which permits the structural element to take both in-plane stresses and out-of-plane stresses relatively well. It should be noted that there are other types of CLT members, dowel laminated, nail laminated, glue laminated, but for the sake of today's conversation, and for most conversations, we'll be focusing on CLT. So some of the mass timber benefits. First off is the aesthetic benefit. When properly treated, the element could be left exposed, and that is highly desirable for folks such as architects and the end user. Furthermore, we have increased function. So timber structures were initially capped at around 6 stories or 85 feet in height, most related to fire and general structural safety per the International Building Code. But with the advent of this new material, we have been able to increase that, as shown on the right-hand image, with the structures able to reach about 9 stories in this case. And then finally, actually, one other thing I'd like to add to this is the fact that the material itself is lightweight compared to steel and concrete. So if you have an existing structure, you can just plop a mass timber element on top of that and get more use out of that square footage, which would help with high urban density living. Okay, now, key areas. Sustainability, cost, and other considerations. First off, with sustainability. CLT and timber are generally less energy consumptive in terms of its production and the construction. Furthermore, timber as a natural resource stores carbon dioxide, which prevents off-gassing in the future and helping with greenhouse gases. And I do have specific numbers as to how much an average timber element could store, so if you want to know more, go ahead, ask away, but onward. To get more in depth onto the environmental impacts, this one study of the comparing reinforced concrete and laminated timber from cradle, which is the inception and grabbing of the raw materials, to the gate, which is essentially dropping it off at the construction site, goes to show that the environmental impact categories here, for the most part, CLT performs much better than its counterpart, which is further demonstrated in this energy analysis method. So embodied energy is essentially all the energy that is natural resources and that is required to produce the material. So as you'll notice, laminated timber takes a lot more of feedstock energy, so the raw materials to power your machines. But of that energy, the majority of it is renewable. So if you were to chop off these green parts, you would see that in the long run, energy-wise, again, timber wins. This is, again, further substantiated by that same research article, which shows a longitudinal study. So from around 1992 to 2012, we see that the embodied energy of reinforced concrete frames, when compared to mass timber, loses by a considerable amount. So we're at 6.3 gigajoules compared to about 4. Additionally, so moving on to cost and other considerations. From the perspective of a construction manager, you are essentially managing the unknowns and the risks of the costs, the codes, and local jurisdictions, as well as the schedule and the impacts of the costs and codes to said schedule. And that being said, with this being a new material, all of these things bring with it additional unknowns and additional costs, which sometimes shy people away from this new material. But we are here today to demonstrate the research which shows otherwise. So let's start off with the code. Even after like 40 years of research into this material, the codification and standardization for design is still a work in progress. And they actually will not be included until the next cycle of codes that are coming out. With that being said, though, as a quick little history, here is a cut sheet from the IBC indicating that back in the day, with the 2015, you were again stuck with that 6-story limit. But with this new IBC, we can go up to 18 stories, depending on the type of building and its occupancy rating, which is pretty amazing. Not to mention when you begin to have hybrid structures that include both timber and concrete or timber and steel, you can achieve new heights, quite literally. Next up, let's go with we're going to have a little discussion about cost and schedule. And one of the main savings that CLT and mass timber does provide is a schedule savings, which in turn means a cost savings. You're not paying overhead, you're not paying layout, you're not paying rental on various equipments. So why is that so important? Well, for the most part, much like Rogelio and Richard's presentation, CLT is a highly prefabricated material. So you have everything cut to spec and to plan, shipped to the job site, immediately picked off the truck, and then immediately dropped into place. So this further indicates that you're going to need to have a lot of time and money spent into pre-construction to make sure that you have the layout optimized and everything has been prefabricated properly. This is extremely important with CLTs because the error of measurement is on the scale of a 64th of an inch, which is considerably smaller than traditional materials such as concrete and steel. So if you have a hybrid machine or a hybrid building, that's going to be you're going to need to account for those differences. Furthermore, you need to account for various holes and openings and hatchways and access routes for other trades such as MEP, and it is much better and more efficient to have that all planned out and cut into the material prior to its arrival on job site. With that also being said, there was a case study performed by Chagas, Kingsley, and others that looked at comparing these two materials, steel and mass timber, to the traditional concrete structure. especially with regards to cost. So first off, they did a schedule savings, which showed that, again, mass timber has a considerable amount compared to its competitors. Furthermore, one of the key issues that people have always been saying is that mass timber is too expensive. There's a lot of problems. We can't afford this new material. And that's usually because they're only looking at the raw material and the install costs. If you were to go through several passes, which include other factors such as general conditions or urban site logistics, because, you know, if you just got a truck, it comes, it drops stuff off, you pick it off in an hour, you know, it's much easier than you have to lay out massive amounts of room for steel. And then the fact that the timber could also serve as its own finish, the cost comparison is minor to negligible, meaning that this is a viable material for future work. But if you switch horses midstream, or if somebody discovers an unforeseen existing condition and you have to change the design, there could be a massive penalty in terms of budget. It's like a 6.5% increase, as stated in this research article. And this mostly stems from change orders related to the design as requested by consultants. They don't say which ones, though, so who knows. Further study. And with that being said, the role of the engineer. We have a unique ability to both synthesize the code requirements and understand the manufacturer limitations to better optimize the design for cost, which is shown in some of these images. For example, this study looks at a bay size, a typical bay size, and finds the most economic building type based on the IBC requirements. And this is that image in table form with the most cost-efficient method shown. So again, it's very plug and play. Similarly, in this case study, the Plat 15, we have, again, proof that mass timber and concrete combo wombo is a much more economic option for this structure. With that being said, CLT, mass timber, is a viable new material, and there's a lot of work that needs to be done in terms of researching its safety and better codes, but all in all, exciting. Thank you for your time. I only went 30 seconds over, maybe 40. I open the floor to questions. All right. So thank you all to anybody who's stuck around this far into the video. Thank you for watching. Thank you for your support. I look forward to making more videos for you in the future. Keep an eyeball out for what is structural engineering. And have a magical day. This is your captain signing off and sailing on. Yeah. Boom. All right.